We now introduce you to the side opportunity to prove triangle congruency. So if the three sides of one triangle are congruent to the corresponding three sides, so for example, AB corresponds to XY, BC corresponds to YZ, and CA corresponds to ZX. Notice that corresponding means that every one part corresponds to the other one. So if we're looking at twins, for example, the left eyeball of one twin corresponds to the left eyeball of the other twin. So if the three sides are congruent to each other, and let's go ahead and label these appropriately, right? So these hypotenuse correspond to each other, and then these three are congruent. These ZX is congruent to CA. Then we can say that triangle ABC is congruent to triangle XYZ. And note the beauty of this, right? Of this if then. So if I can get all three of these pairs to be congruent, then we can prove the triangles are congruent. So we don't even need an angle to prove congruency. And remember, the way this works out is if I have two twins, right, and I say, okay, their eyes are the same, and their arms are the same, and their legs are the same, right? I'm just saying, like, if three parts of the twins are the same, then all the parts of the twins are the same. So what we're saying here is if the three pairs of sides are the same, then boom, the whole entire triangles are congruent to each other. So that means that the angles technically would be congruent to each other as well. We're not going to be focusing on that right now, but like I brought up in the previous video and the future videos, proving triangle congruency is kind of a shortcut. If I can just prove that three parts of the triangles are the same, then everything else is a free giveaway. So which of these can we use SSS on? Well, if we look at these two triangles, you'll know that this pair is this side is congruent to this side. We see this side is congruent to this side. And finally, we see that this AB is congruent to DB. Because all three sides are congruent to each other, all three pairs of sides are congruent to each other, then these triangles are congruent. So we could say triangle CAB is congruent CAB to EDB. Remember to keep track of that order. Remember corresponding parts, all that kind of stuff. If we look at this second one, I do have this pair of sides is congruent. And by the reflexive property, I could do this because they share the same side. So for example, I have that PQ is congruent to RQ. That was given to us. And I can also say that SQ is congruent to SQ because of the reflexive property. But how do I prove that PS is congruent to RS? Well, we can't. It wasn't labeled, and there's no other shortcuts. I don't know if this is the midpoint or not. We don't have enough information. So at this point, I only have two pairs of sides. I don't have a third pair of sides, so I can't prove this by SSS. I can't even prove this with SAS because I don't even have an angle that was given. So as we develop a better intuition for proofs, I wanted to take this opportunity to look at this picture and identify two things that I must know for sure in order to prove this thing. So for example, using the SSS, if I needed to know two things for sure, I know we need three things, but if I must know two things for sure, it must be that this side is congruent to this side, and it must be that this side is congruent to this side. And here's why. Because if I have those two things for sure, then I can use the reflexive property to pull off the third one, and then I'll have all three pairs of sides. Now here's something to think about a little deeper. What if I wanted to do the SAS on this? Side angle side. Well, you know that by the reflexive property I'm going to get this. So we don't need that, right? We're requesting two pieces of information. I can pull off the reflexive property in this one, so I don't need that one. But if I want to go ahead and use the SAS, that means I either need these two sides congruent with these two angles congruent, or I would need these two sides congruent with these two angles congruent, because then I could pull off this reflexive property right here and get side angle side. Or if I did the other ones like that and I have this reflexive property, then I have side, angle, side. So just for kicks, I'm going to pick LKJ, angle LKJ is congruent to angle MKJ, and then those two sides. So for part B, I think we've established this pretty well. What third piece of information could be found based on the above diagram? Well, that's that JK is congruent to JK, and that's because of the reflexive property. And that would be our third piece of information that would be necessary to either prove this with SSS or SAS. Of course, this video is focusing on SSS, but I wanted to go ahead and take some time to bring in former SAS use. Summary: what are corresponding parts between triangles? So when you keep hearing that phrase, what does it mean? Well, that leads right into problem 3. So we have the same diagram again, and we're given a couple of things. We're given that LJ is congruent to MJ, and LK is congruent to MK. We want to prove these two triangles are congruent. May I strongly suggest that you seriously pause the video and take a moment to either write a paragraph proof or a 2-column proof. I'm going to be showing you a paragraph proof, but I would strongly suggest pause and take some time to see if you can prove this. You'll need to prove this with the SSS. You're going to need 3 parts. We already gave you 1 pair of sides and 1 pair of sides. When you get all 3, you can claim this by the SSS. Take some time. Try it out. Pause. So here's a paragraph proof. We know we're given 2 sides already, right? We're given this pair of sides and we're given this pair of sides. The third side is JK is congruent to JK because of the reflexive property. So then this gives us our third pair of sides. By the SSS, we can prove that the 2 triangles are congruent like we were asked to do. And that's it. We're done. I'll be doing a 2-column proof for this one with statements and reasons. But let's see what they gave us. They gave us that NR is congruent to PQ. Sorry, let's do that correctly. All right. OR is congruent to OQ. Now, if we're going to be doing the SSS, we need this third pair of sides to be congruent. But they didn't give us that. They did give us this information. O is a midpoint of NP. Now, if you're uncomfortable with this topic, I would suggest going back to the video on midpoints and bisectors, and if you need a quick refresh on that, check out your notes or rewatch the video on midpoint. So we'll go ahead and make our statements and reasons. So we have 2 pairs of sides already. We have this pair of sides and this pair of sides. So we either need an angle in between them. So in this case, if I wanted to do the SAS, I would need this included angle R and angle Q. But there's no way we're going to figure out that those are congruent because it wasn't given. They're not vertical angles. There are no parallel lines. So that's out of the question. So we'll need to find a third pair of sides. Now, O is a midpoint. And if O is a midpoint, it bisects. Okay, because by definition, the midpoint bisects. Or, in other words, it creates 2 congruent parts. So I can say that NO is congruent to PO. No PO. All right. And that's our third pair of sides, by the way. So now we have the 3 pairs of sides. That's the SSS. That stands for side, side, side. And notice the reason SSS never goes on the left side. It goes on the right side under the reason column. With the 3 pairs of sides proven to be congruent, we can finally state that the triangles are congruent. And this is by the SSS property, or postulate, or theorem, whatever you want to call it. For this summary, what 3 pairs of parts are necessary to prove that 2 triangles are congruent using the SSS? Take some time to think about that.